Good afternoon, students. The topic we are going to study under MLOps today is structuring your MLOps. In the previous classes, in the first module, we learned set of machine learning algorithms like supervised, unsupervised, reinforcement learning, federated learning, the various kinds of multitask, multi-instance learning type of algorithm we learned. The basic concept of that various types of machine learning algorithm was based upon the problem only we can fit the proper algorithm to create a proper machine learning model. That is very, very important. Identifying the problem statement, and we have to think what are the input data sets we are giving to create a model and what would be the output. Based upon that, we have to decide whether it is a supervised, unsupervised, federated, or a hybrid algorithm. Okay, that is decided in the previous steps. So this topic shows about structuring the ML operation. So the structuring the ML operation is done within the organization, because in an organization or a software company only, this machine learning models we are creating as a team. Okay, the machine learning MLOps team may have a developer, then testing team, then deployment team, after that monitoring. Okay, so the development is a separate team, testing is a separate team, then deployment is a separate team, after that monitor. Every thing is done under separate control as a different teams. So there must be a collaboration needed to create this model, and for further deployment and monitoring, we have to monitor how the specific models are performing. Is there is any bugs or error coming? Everything we have to analyze, and we have to keep track of each and every models. Okay, so the structuring of MLOps is represented or carrying over within the organization. It's a team operation. Each team is collaborating with one another in an efficient manner to create a better machine learning model. That is very, very important. So this within an organization, this MLOps team is structured based upon the categories of data, or we can say based upon the size of the data, these teams are formed. Okay, so before talking about the size of the team, we have to know about the various types of data. Okay, so nowadays we are using the term big data. Okay, but in olden days we are not using the term big data. Why this big data term is came? Because in the we are using the every communications through online, we're buying products through online, whatever it is, we are getting a support or searching in the Google. Okay, so in that case, various data are generated in the system, in the network. Okay, so because of the plenty of data, that is named as big data. Okay, so there's types of data are there, which is small scale data, medium scale data, and big data. So if it is a small scale data, means that data is in the size of less than 10 GB. So that data we can accommodate within our own PC or laptop. Okay, so if the data we can store within our own personal system, which is less than 10 GB, we can say it as a small scale data. And medium scale data means if it is between 10 GB to 1 TB, terabyte, we can say it as a medium scale data. So we need a small server to store this kind of data. So it is medium scale. So when we are saying it is a big data, when we are using the term big data, means the size of the data is over 1 TB. Okay, above 1 TB, which cannot able to fit into the single server. In that case, we are using the term big data. The size of the data is over 1 TB, we can call it as a big data. So we are using this big data within this machine learning operation, because we know basically a machine learning models we are creating with the support of input data. We are feeding the models with some set of input data. That input files or input data is separated into training data, testing data. So we need a data. Whatever data we are using within this machine learning model, that may be mostly big data only. Okay, so based upon the size, we are categorizing this or structuring this ML operation within an organization. So the categories are small data operation, big data operation, hybrid machine learning operation, then large scale MLOps. Okay, small scale means a small team with limited resources, and big data ops means for a larger team which are dealing with big data. And from the big data, hybrid and large scale, the organization or a team is working only based upon the big data. So we will see a little clear about these categories of data in the next slide. Okay, so this is the architectural diagram we are using for structuring the MLOps. So first one is the small data team. Okay, small MLOps team. So the explanation given for the small team is it's a very small team. There, the team only consists of data scientist. There is not necessary for a software engineer or MLOps engineer. Only a data scientist is needed to form a small team, small MLOps team. Okay, we are not processing any big data. Small set of data only we are processing, like a small Excel sheet, Word files, some set of small image files we are processing. That is called as small team. And big team means in that place we need a data scientist, software and software engineer. Okay, we need the collaboration of both the data scientist and the software engineer in the big data ops. Then in the hybrid operation model, we need a team which consists of data scientist, data engineer, and DevOps engineer. So the machine learning model is mainly based upon the deployment. Not only we are creating a model, we are creating a model, after that deploying to the real-time environment, and we are monitoring how our performance of the particular model, whether it is performing well. So there we need a DevOps engineer in a hybrid team. Okay, in hybrid team we are processing a big data, and only narrow range of operations are carried over in the hybrid ops. Then the fourth one is larger scale MLOps. Here also we need a team which consists of data scientist, data engineer, and DevOps engineer. There we are focusing on very big data operations, which is carrying over with multi-scale MLOps operations. Okay, multi-scale model, very big model creation. In that cases, we are using the large scale MLOps. Okay, this is the architectural diagram. And the explanation, the characteristics, the drawbacks and example when we are considering under small data operations is, from the title itself, we are not using a big data in the small data ops. So there is a small team with limited data and rapid prototyping model we needed. This is the characteristics of small data operations. But the drawback of this small data operation is sometimes because of less clarity, repeated work is carried out by the different set of peoples at the same time. Okay, so there's a lack of transparency. Yeah, small work is carried out by various members, so it requires high cost. Okay, so this was the drawback or common pitfall in the small data ops. So this kind of organizations may called as small startups with small data sets. Okay, a small company which is creating a web-oriented development. They are developing a website, designing a website, or one small application, or any one small gaming related software they are preparing, means they are called as small data operations, which is comes under a small startup. Then the second one is big data operation. So here, the title itself, we are using a big data, large set of data in this MLOps team. So this team is dealing with the largest set of data. So they are using the tools called as Kafka and Spark for processing this big data. But there is a also drawbacks are there. So this big data operations are used by little bigger or small scale organization which is having a large scale data processing. The organization may be smaller, but they are processing with a large set of data. That's why they are using this kind of Kafka, Hadoop, and Spark tools. Okay, so the drawbacks are lack of transferability, then reproducibility issues and high cost. And for processing this big data ops, we need a GPU and TPUs to process the data because we are processing a large set of data, so the speed of the machine would be higher. So we need the GPUs and TPUs here to train the model and test a model. Okay, then the third one is hybrid MLOps. So here we need a data scientist, engineer, and DevOps engineer. So there must be a collaboration needed within these three teams. They are concentrating and processing with big data, like our every day the data is generated from the e-commerce websites like Amazon, Flipkart, okay, Netflix, Gmail account, WhatsApp account, everywhere the plenty of data are generated. Okay, there we can use this hybrid machine learning models or a CCTV camera. From a CCTV camera fixed within an organization or a school, company, whatever it may, generating a high number of big data. Okay, so if you want to process or create any model using that kind of data, means that to be comes under this hybrid MLOps. Okay, the drawback here is inefficiencies in monitoring and high cost because of the repeated work. And because of three teams, we need a better collaboration and high collaboration with the different teams. That was one of the drawback. The tool we are using here is PyTorch and TensorFlow to process this, to process or create a hybrid MLOps team within an organization. Okay, so the hybrid MLOps team must have the knowledge of using the PyTorch as well as TensorFlow. Then the next one is large scale MLOps. So this large scale MLOps are used in the very big MNCs like TCS, Google, Amazon, etc. Okay, so this large scale companies are processing big data with multiple machine learning models. They are working with the different machine learning models with the different kinds of algorithm. Okay, so there also the pitfall is high cost and intangible system. Like in the previous topic, we discussed about GPU and TPUs. Okay, like that, different processors, higher processor systems, we need to process this kind of model. And this model is working on the different kinds of resources, multiple resources. Okay, so there is a need of a very big and multiple team to process this large scale machine learning operations. So it is complex to form a large scale enterprise team and process a large scale machine learning operation model. Okay, so this is these are the structure or phrasing, structuring of MLOps team within an organization. So as we discussed, the structuring your MLOps means we are framing a group within an organization to create and process a machine learning operation or a machine learning model. That is called as structuring the MLOps. So there must be a team collaboration is necessary. So this team is framed based upon the size of the data. So the size of the data can be in three types: small scale, medium scale, and big data. So based upon the size of the data they are processing, we are framing a team to create a machine learning models. So that teams may be called as small data operation, big data, hybrid, and large scale MLOps. In a small data team, only we need a data scientist. There is not necessary for others like DevOps engineer. So only a data scientist is needed, and they are processing with a small set of data, which is a small startup companies. Okay. Then the second one is big data operation. There we need a data scientist and a software engineer. Only coder is enough. So there we are using a little bigger size of data, but they are focusing only to the very specific problem or a small problem they are focusing, which is called as big data ops. Then in hybrid ops, the team we are framing is data scientist, data engineer, and DevOps engineer, because here we need a deployment in hybrid as well as large scale model. Okay, so they are focusing on narrow range of operations, but it carries over with large scale data. That's why we are using TensorFlow, PyTorch, that kind of tools we are using here. Then under large scale, also the same kind of teams in hybrid, we are using data scientist, engineer, and DevOps engineer. So they are facing with a large set of different kinds of machine learning models they are generating, and that models is working based upon various resources. So the making a collaboration between this large scale MLOps team is very, very tough. Okay, so this is about structuring your MLOps teams or structuring MLOps. Okay, thank you.